So again, if anyone wanted the title, we are tackling actually two theorems today, remainder theorem and factor theorem. And what you guys are looking at on this first one is the lead-in, or the part of this problem that we're going to use to explain our remainder theorem. So if I get rid of this little shade here, it's going to talk about your remainder theorem. And the remainder theorem says this. I mean, that's the mathematical words behind it. If a polynomial is divided by a factor x minus c, the remainder, which in our case is 12,572 negative, is the same answer you get if you were to have just plugged the 0 into the function. Okay, so kind of pointing that out, the remainder when we divided is the exact same answer we would get if I had just gone to my function and plugged the 0 into that. I would get that exact same answer. Okay. Now, this situation is not necessarily something I will use that for, but when we get to the end of our notes today, we're going to come back to this whole concept of the remainder theorem and use this idea to really speed up our process. So we're going to hopefully, if you understand what's going on here, help ourselves not have to do as much work when we get to the end of today. Okay? And that's just understanding that when I plug a 0 into a function, the answer I get at the end of plugging it in is the exact same thing I would get as the remainder if I were to divide using that same 0. Okay? Moving forward from that, we're going to talk about this thing called the factor theorem. Okay, now we are going to do 4 examples of this factor theorem because there's basically 4 different varieties of things that can happen handed this information. So it says use the factor theorem to determine if the binomials are factors of f of x. So let's talk about that first sentence in the directions. Use the factor theorem to decide if they are factors of our polynomial. Well, to decide that, what we are going to do to decide that yes, in fact, it is a factor of my polynomial is we are going to do synthetic division. Okay. And if we get a remainder of 0, it is a factor of our polynomial. So that's what we are looking at when we are done with this. Do synthetic division, remainder of 0, it's a factor of our polynomial. Then the second sentence, use the binomials that are factors to write a factored form. So at the end of this, my answer should look like parentheses, right? That's what it means when it asks me to write factors. So again, picking out from our directions what format they want our answer in. And in this one, they want it to be factored in parentheses. So what they're handing us is a polynomial. F of x is this guy. And then they're giving us 2 possible factors. They're saying, hey, try these out. They might work in this polynomial as factors. Okay? So to try it out, we do our synthetic division. So I'm just going to set up my synthetic division using my coefficients here. And we're just going to take turns and try out the different factors they gave us. So they gave us x minus 2. They said, hey, that might be a factor of this polynomial. Try it out. So I try it out. And again, if that's my factor, x minus 2, what do I write out here? 2, right? From the factor, we go to the 0. The 0 is what goes outside of our synthetic division. Go through my synthetic division. 2 times 3 is 6, minus 1 is 5. 2 times 5 is 10. Negative 22 plus 10 would be negative 12. 2 times negative 12 is negative 24. And we get a remainder of 0. And that's the number we need to look at. The remainder. The remainder tells us everything. If the remainder is 0, that is a factor of my polynomial. Okay, so there's 2 things that happen that I want you to do when the remainder is 0. First of all, you're going to go to wherever you are putting your answer and include that factor as one of the factors of our answer. Okay, it is a factor of that polynomial. The second thing is this. If this is a 0, you get to use the leftovers to test out any other 0. What do I mean by we get to use the leftovers to test out any other 0? Is that these numbers are what I call the leftovers, 3, 5, and negative 12. I now get to just use those to try out the x plus 5. Okay, because it's a 0, only because it's a 0. If this is not a 0, we don't get to use those numbers. Okay, So now I go to synthetic division a second time, just using my leftovers. And I try out the other option, x plus 5. So again, that's the factor. I put the 0 out here. If it's an x plus 5, the 0 is negative 5. Try it out. Negative 5 times 3 is negative 15. Plus 5 is negative 10. Negative 5 times negative 10 would be 50. Minus 12 would be 38. That is not a factor. A remainder that is not 0 means that is not a factor. So this will not get included on my answer. And we don't get to use the leftovers, okay, because it's not actually a factor of our polynomial. All because this is not a 0.
Should we always start with which set is used first?
That's a good question. It will not make any impact on your answer at the end. It might look a little different in the middle part of it, but our answer at the end will be the exact same. And we're going to go through every variety where they both work, they both don't work. The first one doesn't and the second one does. So we'll see all of the different possibilities through the rest of our examples. So here's the tricky part about this order, where the first one works and the second one doesn't, is that to get the rest of your answer over here, you have to go back to the one that worked. Okay, so it worked here at 0. We have to go back and we have to take, because remember, these numbers work, right? I have to go back and take those and add them to my answer as a polynomial. That's the tricky part about this one, because this didn't work. I can't use that. I have to go back to what did. So 3, 5, and negative 12 in polynomial form, 3x squared plus 5x minus 12. And it does ask us to make sure that it is fully factored. As always, we would look to see if what I have on my line of the answer is fully factored. Now, x minus 2 is factored. 3x squared plus 5x minus 12, possibly not factored, right? So now I'm going to try out my method, whatever my method is. Slide and divide, which, by the way, on a lot of our homework quizzes, I've been putting the and divide reminder on there. So if you are a slide and divider, don't forget and divide. Try out your method. Is that one factorable further? Give you a second to try that out. If it is, we factor it. If it's not, it just stays as is. Factor how you know how to, yeah, you don't have to use slide and divide. Oh. Come see me. Okay. All right. Hopefully you decided that yes, it was factorable. It is factorable. Okay. So we're going to keep factoring. Factor our first term, 3x and x, factors of negative 12, and I need a middle term that's going to be a positive 5. That'd give me negative 12, positive 9, negative 4 is going to give me a positive 5 there. Now factored, that would be our fully factored form of that polynomial. Okay, so like I said, we've got 4 examples of this because we're going to see one of each variety. First one worked on this one, second one did not. So let's see the other options here of when they both work, both don't work. First doesn't, second does. Second example, f of x equals 4x cubed minus 34x squared plus 54x plus 36. They give us possibilities of x minus 6 and x plus 3. They're saying, hey, those might work. Try them out. I set up my synthetic division, and I try each of those possibilities. Again, they're handing me the factors. I'm going to do the zeros outside my synthetic division, so x minus 6 is going to look like a 6 out here. And I try it out, looking for a remainder of 0 to keep it as a part of my answer. 6 times 4 is 24. Negative 34 plus 24 would be negative 10. 6 times negative 10 would be negative 60. 54 minus 60 would be negative 6. 6 times negative 6 would be negative 36. So again, a remainder of 0. So 2 things. I add that to my answer. And I get to use the leftovers. So now I get to use the 4, negative 10, negative 6 to test out our other possibility. And the other possibility is x minus 3. So that's my factor. The 0 would be 3. Go ahead and do my synthetic division using 3. 3 times 4 is 12. Negative 10 plus 12 is 2. 3 times 2 is 6. So here's our variety where both work. I got a remainder of 0 a second time. And any time, at any point, I get a remainder of 0, that is a 0 of my function, or that is a factor of my function. X minus 3 would get included on my answer. And then here's where we have to finish out our answer. Other things included on our answer is any of the numbers by our last 0 here. So this is also a factor of our polynomial. And there's only 2 of them, so this will start out as a 4x to the first, right? Plus 2 is what that would look like. And always finishing out our problem by making sure that it is fully factored. Now, I don't see any x squareds in there, so that it would initially make me think that it is fully factored, but does anyone see what I'm missing on this? The GCF, right? The 4x plus 2 has a GCF of 2. Jordan?
For 3 numbers, it would be something x squared plus x plus.
Correct. Yep, correct. So I'm going to take out the GCF of 2 here. You don't necessarily have to keep it in this order. As long as you have them all in there, order does not matter. I always write the GCF out front because that's how you typically see it written. That would be our fully factored form. So there's your one example where both options that they handed us worked, and we get to that factored form. Yes?
It doesn't matter which one you do first.
It does not matter which one you do first.
When I did like x minus
Yep. Ooh. When you did the 4, negative 34. Let's try it out real quick. If you did, we'll help you find your mistake. So you did the 3 first? Did you do 3 or negative 3? Okay, there. So let's see, that'd be 12. This would be what? Negative 22. So 66, negative 12. Happens. Happens. Make sure that we, guys, when you get calculators on this, I can't tell you, I mean, the other day I was doing a problem and got it wrong because I wrote down that 7 times 4 was 21. Okay, and it's so easy to do that all the time. So, yeah, happens. If you have time, we're always going to go back and double check with our calculators. All right, next one. So we've seen now the variety where both work. Got to see another variety here. Next function, x to the 4th minus 2x cubed plus 24x squared plus 18x plus 135. We're testing out x minus 5 and x plus 5. We don't have this in our notes today, but just a constant reminder that when you are doing synthetic division, look for missing terms. That's going to be probably our most common mistake that happens on these, is that we forget to fill in a missing term with a 0. So make sure that we are always looking for that. All right, if I try out this first one that is x minus 5, my 0 would be a positive 5. Working our way through this one, 1 times 5 is 5, minus 2 would be 3, 5 times 3 would be 15, plus 24 would be 39. Let's see here. I can quickly see that this one is headed the wrong direction, but let's see what we actually get. All right. So this is our first time that the first one we tried did not give us a remainder of 0. So we got to see what we do here. Because this is not 0, we can't use the leftovers. So I do not get to use these numbers if that is not a 0. We have to just reset. Okay, go back up to the original polynomial numbers and try those out with our second 0 to see if that one works. So when that first one fails, you gotta reset. Okay, our second 0 would be negative 5. Going through. here, let's see, -5, -7. All right, so here's our variety where both options that they gave us didn't work. So how then do we write an answer? How am I supposed to factor this? Well, guys, right now with the utensils that we have to factor a polynomial, we can't. We cannot find factors of this one if the possibilities they gave us don't work. So guess what? The original problem is as factored as this is going to get with what we have to be able to factor a polynomial. Can't factor an x to the fifth, and what they gave us didn't help us out. So we would be done with the original. So there's your variety when both options don't work. All right, we've got one variety left. Here's our last variety. 4x to the fourth plus 21x cubed plus 25x squared minus 5x plus 3. Here's our last combo. Let's go ahead and get our synthetic division running here. All right. So first time I'm going to try out the x minus 1, which means I've got a 0 of 1. Try that out here. So we'd get 4, 25, 25, 50. 50 minus 5 would be 45. Plus 3 would be 48. When that is not a 0, I don't get to use the leftovers. Reset. Okay. All right. This time I'm supposed to try out -3 times 4, 12, if I can do that. Plus 21 would be 9. 3 times 9, -3 times 9 would be -27. Plus 25 would be -2. Times -3 would be 6, which is 1, -3. And there's our last combo. First one didn't work, second one did. So a reminder on what we do when our answer works. We go down to the answer line, and we include that factor on our answer line. Then we take what works. So the last one that worked, those are the coefficients of our polynomial. If I've got 4 numbers there, this is going to be a 4x to the what? Third, right? So I start at 4x to the third and work my way down here. As always, especially if I have something greater than an x to the first, I look to see if it is factorable further. Now, if I've got 4 terms, what's the only method we have to factor something like that? Grouping. Is this one factorable by grouping? No, because if I take out a GCF on those, the leftovers are not going to match, and that's what I look for to be eligible to factor by grouping. So this is just kind of like your last variety of things you're going to see. Sometimes what's left over is not factorable further, and we would be done at that point. That is as far as we are able to factor that problem. Any questions for me? All right, hold on. Before you guys pack up, we do have one question left. It's just not this variety. On this last one, it is a calculator-heavy question. So grab your graphing calculators, and I will tell you right now that you are going to need to take good notes for yourself. This is not a watch me and know how to do this problem. Make sure you jot down for yourself so that when you run into this problem again today, you know what to do. Okay, I know that it looks ugly to start with. Your calculators are really going to help us out on this. It says use a graph and synthetic division to completely factor the polynomial. We don't know how to factor an x to the fifth, but we can work this down using synthetic division to something that we know how to factor. So what I need you guys to do right now is type this function into your y1, to use this picture up here to help you set your window. I'm going to give you a minute to get that in your calculator, and then I will put my calculator up on the board and kind of help us through that. So if you're having trouble with the window or anything, I will get that up there, but again, make sure that you are taking good notes for yourself as to how to attack this problem so we know what to do next time we run into this. Okay, I will help you with what those numbers are because I know they're small and kind of hard to see on the graph there. So everyone got that typed into their calculator at least? Okay, let's talk window here. I've got it typed into my Y1. I'm going to go adjust my window to the same window that I see over here. So here's what I adjusted to. -10 to +10 on our x-axis. They have it numbered by 2, so I changed my x scale to 2. That's not really going to impact anything if you left it at 1. The lowest number on there is -2400, so change your y minimum to -2400. Change your y maximum to 5600. That's the highest number they have on there. And then their scale is marked in 800s. So if you'll change your scale to 800 for the y-axis, that way we don't have 5600 little tick marks running up the side of our graph. Once you have that set, let's go ahead and hit graph. Is it all right if I click graph here? Anyone need this still? All right, and then we see this picture happen. So first of all, I'm going to go draw this for myself a little bit so we can kind of talk about this. Not too bad. Something like that, okay? But here's what we know. We know that if we have a 0 in our picture, meaning where it hits our x-axis, that is a 0 of our polynomial, or its factor will factor our polynomial, and we can use that when it does its synthetic division, and we should get a remainder of 0, right? So I can use my calculator to help me find those 3 places, so that's at least 3 of the zeros of this function that I know will work when we do our synthetic division. So let's go use our calculator functions, which remember is going to be our 0, so second trace 0 option. And I'm going to let my calculator tell me where it's hitting the x-axis there. So I'm going to move a little bit left, hit enter, move a little bit right, hit enter, enter to skip guess, and it tells me that it hits our x-axis at -6, which means I know I have a 0 of -6. It hits my x-axis again right there, so I'm going to go find that one. Closer over there, a little bit left, hit enter, a little bit right, hit enter, enter to skip guess. I've got another 0 at -2.5. And then the last one we need to talk just a second on as I go find this. Because of what we are using these for here in just a second, I have to keep this exact. I am not allowed to round something like 2.3 repeating. So if I see a 2.3 repeating, what is that exactly? 2 1/3, right? So keeping it exact, not rounding an answer, and I have to be able to type this into my calculator. So 2 1/3 is what I would use instead of the decimal that is repeating, because I can't type repeating into my calculator, right? So then what are we going to use these for? Well, I know that if I do synthetic division with each of these, I'll get an answer of 0 and I can use the leftovers, right? And every time I do that, it brings my degree down 1, doesn't it? Every time I do synthetic division, doesn't it bring our degree down 1? Well, if I'm starting at a degree 5, I need to get it down to like a degree of 2, an x squared. I can factor an x squared. I can't factor an x to the 5th. So that's what we are going to go to. Let me actually adjust this real quick so I have room to write. All right. So using those zeros, I'm going to do synthetic division. Does it matter the order? Not at all. Pick whichever one you want to use first. I personally am going to use the -6 first because it's less things to type in my calculator. So I know what the answer at the end is going to be. It's going to be 0. But I have to do the work because I need to know what the leftover numbers are. But I'm definitely going to grab my calculator because these are going to get a little ugly. And that's a lot of mental math. Yep, I'm going to use -6 first. Okay, so I'm going to grab my calculator here. Do -6, let's see. Now, I am expecting to get 0 at the end, and if I don't, I'm going to go back and figure out what happened because something went wrong. I know it's a 0 of this function. I know I should get 0 at the end.
You know that, or you should all know that?
We should all know that. Because zeros of my function, anytime it hits my x-axis, is a 0 of this polynomial, and if you do synthetic division, your remainder should be 0 when we do that. Let's see. Okay, so good sign that I got 0 at the end. Okay, and do we have to know all of those zeros? You do not if we get to a point that we could factor before we used up all 3 of them. But like right now, this would be like a 6x to the 4th minus 23. I can't factor that polynomial yet, so I have to use another one at this point. But if we were to ever hit something that I could factor, you wouldn't have to keep using those. You could just stop and factor. But I don't know. I don't know how to factor that still, so I'm going to do synthetic division again with another 0 that I have. So we've used the -6. Now I'm going to go to like -2.5. Do synthetic division again. And again, I know that I'm going to end up with 0 at the end. And if I don't, I'm going to go back and check what happened, because something happened that I didn't get 0, because it should be. So let's say 2.5 times 6. Okay, another good sign. Got to 0 again. And again, we could pause at this point and say, if I were to write this, my leftovers, out as a polynomial, if that was something that I realized that I could factor, you could stop there and factor. I still don't know if I can, I can't factor that. So I would have to go one more time. Now, here's the helpful hint on this to save us some time typing on our calculator. If you have a mixed number, it's actually going to be faster to type that in as an improper fraction. So 2 1/3 is the same thing. 2 times 3 is 6 plus 1 is 7. And or use the function on your calculator that will convert that to an improper fraction. But it's 7/3. And typing in 7/3 is a lot faster for me on my calculator than 2 1/3. So I'm going to do synthetic division one more time with 7/3. And again, I should get 0 when all is said and done. Okay. Now, getting from here to the actual answer is where people have a little bit of trouble. We know the zeros of this function from the picture, but when we got them out of the picture, they looked like this. You guys a couple days ago had a problem where I asked you to go from the zeros to a polynomial, and in that process had to go to the factors. But instead of looking at it like this, we had them all as improper or just fractions. It'll be a lot easier for you to write the factor if you were to write these as the improper fractions than as like 2.5 and 2 1/3. So instead of this list, I would look at it as this list. Now negative 2.5 would be negative 5/2. And we already converted that one. So we know, we already practiced this part. I know how to take those and make them into factors. That would be x plus 6. We talked about if it's a fraction that the denominator goes in front of x. We use the opposite sign. That is what follows the plus or minus. Same thing here, that 3 goes in front of the x, minus 7. Okay, are we all remembering how to get fractions into factors? Good. The last part is, remember we have to use the leftovers for our last 0 there. So we would have 6x squared minus 24x plus 24. Now, for some reason, my board will not let me move that down. So let's go ahead and talk about that last polynomial I just wrote down. That's not done factoring, right? Has a GCF first, so start there. And look for factors of 4 that add up to negative 4, which exist, right? X minus 2, x minus 2. So writing out our final answer, we have a GCF of 6. We have 2 x minus 2's, which I can write as x minus 2 quantity squared. And don't forget all of the rest of them. Fully factored form. Questions?